Good morning, algebra, or afternoon, whenever you're watching this. Today we're solving linear equations by graphing. So we were solving equations algebraically. Now we're going to solve them graphically. You can solve an equation by graphing the related function. The solution of the equation is the x-intercept. So we learned this last time. The x-intercept is where the line crosses the x-axis. That is the x-intercept, where it crosses the x-axis, and it's our x value because y equals 0 at that point. So solve the equation 2x minus 2 equals negative 4 by graphing. So we've done this algebraically. We add the 4 over, or we add the 2, add 2 over, divide by 2, and we solve it. But they want us to do it graphically. So the first thing you're going to do is you want to set this equation equal to 0. So we get 2x minus 2 equals negative 4. We want that to equal 0. So in order for that to equal 0, you add 4 to both sides. And notice these 4's cancel out. So then you get 2x minus 2 plus 4. Negative 2 plus 4 is 2. So you get 2x plus 2 equals 0. 2x plus 2 now becomes our function. And you notice where it says f of x is another way of just saying y equals. So we can graph that equation. What we're graphing is y equals 2x plus 2. And when we did this, this is now in what we call slope-intercept form. So they want you to make a table, but I'm actually going to teach you differently. You can make a table like they're doing, and you fill in the x values, you fill in the f of x values, you get your coordinates, and then plot your coordinates, and then draw your line through it. What I want to teach you is, I want to remind you of slope-intercept form real quick. So slope-intercept form says this: y equals mx plus b. Where, but I'm also gonna change this from y to f of x. So, and we want to remember that m is what we call our slope, and b is our y-intercept. So if x-intercept is where it crosses the x-axis, y-intercept is where it crosses the y-axis. Our slope tells us where to move, how we move, and our intercept tells us where we start. So if we look at this problem, our intercept, our y-intercept is 2. So that's where we start. We go up, y equals 2. That's our y-intercept. Our slope, m equals 2, but I can always say 2 over 1. That means I go up 2. It's my rise over my run. So up 2 over 1. Up 2 over 1. See, I'd be off the graph at that point. So I can go down to left 1 instead, and you notice I'm on the graph. So that's one way to do it. So we've graphed this, and now the goal is to find out where does it cross the x-axis. So where does it cross the x-axis? Well, it crosses the x-axis right here. So that is x equals negative 1. So I'm going to do a couple problems with you. There's 6 problems altogether, and I'm going to do about 3 of them. And then I'm going to leave you guys to do the other 3. All right. So first thing we want to do is we notice that in number 1, 3x minus 3 is already equal to 0. So I'm going to do it both ways. I'm going to show you how to do the table, and then I'm going to show you how to just graph it. So our function that we're dealing with is f of x equals 3x minus 3. So I'm going to do a table. X, f of x, I'm going to make that a bigger one because I'm plugging in, and then whatever that gives us, well, we'll put f of x equals 3x minus 3, and then whatever our value is, f of x, and then we'll call this one y. That's our x comma y. That's our coordinate point. So let's start off with, we'll start off with -1. -1, so I get 3 times -1 minus 3. Well, 3 times -1 is -3. So I get -3 minus 3, which is -6. So my pair is -1 comma -6. Now I'm going to try 0. 3 times 0 minus 3. Well, 3 times 0, that cancels out. 3 times 0 is 0. 0 minus 3 is -3. So my point is 0 comma -3. And then we'll do one more here. We'll go orange. We'll go 1. 3 times 1 minus 3. 3 times 1 is 3. 3 minus 3 is 0. X comma y. X was 1, y is 0. So I'm going to go ahead and plot those points. So if you notice, -1, -6 is off the graph. So I'm going to go to the next one. 0, -3. 0, 1, 2, 3. 0, -3. 1 comma 0. 1, 0. And then I'm going to go ahead and draw my line. So that's my line. And I'm going to look, where does it cross the x-axis? Right there. What does x equal? X equals 1, positive 1. So that's my solution. So let's go ahead and do number 2. But before I can do number 2, I need to set this equal to 0. So I'm going to rewrite it, -2x plus 1 equals 5 minus 2x. So I'm going to solve this equal to 0. Or I'm going to solve this, set this equal to 0. So I'm going to add 2x to both sides from the right side. I'm going to move everything from the right over to the left. So I'm going to add 2x, and I'm going to subtract 5. So on the right side, -2x plus 2x cancels. 5 minus 5 cancels. So I'm left off with 0 on the right side, which is what I wanted. But then on the left side, -2x plus 2x, the x's cancel. 1 minus 5 is -4. So we have an issue here. Our f of x equals -4. And remember, f of x is just another way of saying y equals -4. So what that means is y equals -4. 1, 2, 3, 4. All the way through. So my line would be right here. And we're looking for, where does it cross the x-axis? Where is the x-intercept? So what we have is it doesn't. It doesn't cross the x-intercept. So what we have is no solution. So that's number 2, no solution. Number 3, it's already set equal to 0. So we're going to just go ahead and say f of x equals negative x plus 4. So I'm going to set up my table. F of x equals negative x plus 4. And then we're going to go to f of x, whatever our answer is. And then we have our x comma y. So let's start with x equals 0 again. We'll start with x equals 0. So then we got negative 0 plus 4. Well, negative 0 is just 0. 0 plus 4 is 4. So my pair is 0, comma 4. Then let's go ahead and do x equals 1. So then I plug in, I get negative 1 plus 4, which is 4 minus 1, which is 3. So 1, comma 3. And then we'll do one more. What if x equals 2? So we get negative 2 plus 4, which is another way of saying 4 minus 2, which is 2. So my answer would be 2, comma 2. So notice, now I'm going to go ahead and plot these points. 0, 4, 1, 2, 3, 4. 1, 3. 2, 2. Notice those points don't cross the x-axis, but I have my line, so I'm just going to go ahead and draw my line. Oopsie. I'm going to go ahead and draw my line. And if you notice, my line crosses the x-axis, so I'm going to put a circle around it. Where is that value? Well, that is at x equals 1, 2, 3, 4. So x equals 4. It froze. So x equals 4. I'm back. So x equals 4. That was my solution. So there we have it. Number 1 was x equals 1. Number 2 is no solution. Number 3 is x equals 4. So I'm going to have you guys do the rest on your own. Notice that for this one, for number 1 and number 6, just estimate the answer. So I'll do number 1 for you real quick. It's already set up as f of x equals, so f of x equals 4x minus 1. So I'm going to do my table. F of x equals 4x minus 1. And then f of x. And then my pairs, x comma y. And we'll start with 0 is a good one. 0. 4 times 0 minus 1. 4 times 0 is 0. 0 minus 1 is negative 1. So my point is 0, comma negative 1. And then remember, I only need 2 points. I only need 2 points for it to be a line. So let's just go with 1. 4 times 1 minus 1. 4 minus 1 is 3. So my point is 1, comma 3. So I'm going to go ahead and plot those points. 0, negative 1. 1, comma 3. 1, 2, 3. Let me draw my line here. And so you'll notice that this doesn't cross the x-axis at a perfect number. So we're just going to estimate it. And I'm going to say x equals about a quarter of the way. So I'm going to say 1/4. So you guys are going to do numbers 5 and 6 on your own. If you copy the work as I've done it, you got the majority of the credit. 5 and 6 would be for full credit. All right, guys, have a great day.